Probably the most common form of printing is what we refer to as four-color offset lithography. And it's similar in process to the fine art lithography I talked about in the previous lecture. But this is more commercialized and mechanized. And the reason we call it offset is because you're actually not taking a plate and printing onto a sheet of paper or another sheet of material here. The way it works, if you look over here on the diagram on the right, the plate that has your design on it is on a cylinder up here on the top, and it doesn't actually touch the paper. What it does is it will rotate around, and then it will place the ink, it will pick up the ink on the rollers here, rotate around, and then what it does is it offsets the image onto a separate cylinder here, and then that cylinder is the one that actually touches the paper and puts the printed image on the page. Why do we do this? Well, especially for huge runs of commercial printing, having the actual plate touch the paper would actually wear it down over time, which would mean you'd have to constantly be replacing the plate. By offsetting it onto a offset rubber cylinder, it makes the plates last a lot longer and makes it much more cost effective on here. So here you can see an example of that where the design is here on the original plate. It is now being offset onto this plate down here, the red cylinder down here, and then that image is what's being placed or impressed on the paper. Now, because you have this extra step in here, you'll notice on the actual plate up here, the image is right reading, which means unlike other types of printing, it isn't backwards. That's because when we added this extra step and offset it, when it goes onto the offset cylinder, now it's backwards, and then when it goes onto the paper, it will be right reading again. We call this the four color process because we use the four process color inks, and I'm sure a lot of you are familiar with these. So these are cyan, magenta, yellow, and black. And going back into the 1860s when this process was developed, it was discovered that if you wanted a full range of color on your printed piece, you couldn't have 30, 40, 50 different colored inks. There had to be a way that you could create a wide range of color, a wide spectrum of color with the fewest number of inks. And what was discovered is if you take your artwork and turn it into a screen of dots and then combine dots of varying size in these four colors, you can get a wide range of color. So the way printing works, and you need to understand this too, is what you're seeing, what reaches your eye, is actually the reflected light off the paper. So the red, green, and blue stripes or arrows here represent, say, sunlight. That would be the spectrum of natural light. So when this light hits a white sheet of paper and reflects off to your eye, what you will perceive is the white of the paper. If I put magenta ink on the paper, then you have the natural light come through here, and the magenta ink absorbs part of that green spectrum, but it allows some of the red and the blue to bounce off, and those mix when they meet your eye and form the magenta color. You can see the same thing happening with the cyan and the yellow. So again, what's happening is light is going through the ink, bouncing off the paper, and then the ink is trapping part of the spectrum, and you're getting the rest of it is what hits your eye and what ends up being visible to you. Now, here's the perpetual problem that all designers run into, and that's what we refer to as the color gamut. So the large wing shape you see here is the full range of hue that is visible to the human eye. And then you'll see these other shapes that are inside there. The large white triangle labeled Adobe RGB, that is the RGB spectrum that is available on monitors using the Adobe software. And then you see the sRGB, that's a similar spectrum that's available on monitors or Microsoft software. And then kind of in the middle there, you'll see that weird kind of polygon shape labeled CMYK. That is the range of color that is able to be printed using the standard CMYK four-color process. So you'll notice there's a lot of colors outside that black shape that really can't be accurately reproduced with standard 4-color printing. This is a constant problem for designers because what will happen is you will have a color that looks fine on your monitor, but when you go to print it out, it's going to end up looking a little darker and duller than you anticipate because the CMYK process can't reproduce it. So color matching is a constant issue that we all have to deal with as designers, and especially if you're working with print, it's highly advisable that you try and do a test print of anything to make sure the colors on your screen are going to reproduce the way you want them to. You'll see this term referenced a lot with commercial printing too. It's called SWOP, which stands for Specifications for Web Offset Publications. This is a standardization. And again, because so much printing work is now done internationally, a lot of work for the United States is actually printed in China or India or other countries. And this is a standard that tries to make sure that anything is uniform no matter where it's printed anywhere around the world. Here you can see another example of that gamut showing you the CMYK swap gamut, which is slightly different than the other CMYK gamut I showed you earlier. Again, the big wing shape indicates what's visible to the human eye, and the other shapes represent the limitations we have both in digital media and in print. So I mentioned with most printing, you can choose a wide range of color spectrum just using this dot pattern. So here you can see a complete enlargement of what that dot pattern looks like if you look at any printed piece through a magnifying glass. Now, when you step back, you're not going to see all the dots and it blends together in more of a continuous tone. But you can see how just those 4 colors in either large or small dots can help create that full range of colors. So with printing, when you send your artwork to a printer, it's going to be turned into a cyan plate, a magenta plate, a yellow plate, and a black plate. These are all made up of dots, halftone dots. When these 4 plates are combined, it's going to end up looking like a more full range of color in there. These dot patterns are all laid at a specific angle, and that's so they don't clash with each other and create something we call a moire pattern, which I'll show you in a minute. So with halftone printing, what you get is this very typical, we call it a rosette pattern, where you can see where all 4 of the dots kind of mesh together and they don't fight with each other or clash with each other. Here you can see a much more enlarged version of how those different angles line up with the halftone dots. When you're working for print, it's important to understand the limitations and the budget limitations on here. One of them is just the level of detail in the screens you're working with. So here's an example for print with a 10 line per inch screen, 45, 65, and 150. So obviously, the greater the number of lines, the more level of detail that you're going to get into that. And that really oftentimes comes down to a matter of budget. Oftentimes you as the designer will be responsible for hiring a printer and setting up all the parameters that you need to work with within your budget on here. Why that's important if you have a design that's got very fine detail on it. So here you can see in this artwork, there's a very fine line work in here. When you have very coarse screens, you can see it kind of falls apart. As you get more detailed and more fine screens, you're going to be able to hold more of that detail in there. It's important to understand the way these screens work, especially working with gradations. Gradients has been a very big trend in print design and graphic design for the last probably 10 or 15 years. But the thing you have to understand is, to the naked eye, this gradation looks very smooth from the blue to the magenta. But when you're achieving that with halftone dots, you can see when I magnify this up, you've got actually really big cyan dots and very small magenta dots. And when we get to the other end of the spectrum, you've got very large magenta dots, very small cyan dots in here. And so that's part of the reason oftentimes in print design, if you do big areas of gradation, it can start looking a little bit banded and not as smooth as you'd like. This is also a good example, too, of understanding the material you're printing on. So obviously, if you're printing on a very porous sheet of paper, these dots are going to spread out a little bit and may not be as uniform as you like. Now, there's another way of screening as opposed to halftone dots, and that's referred to as stochastic screening. The difference is in conventional halftone dots, the dots get bigger or smaller based on how much of the color is needed at any one point. In stochastic screening, the dots all stay the same size, but where you don't need a lot of them, you have very few dots. Where you have a lot of the color, you have a lot of the dots. So it's very similar to stippling if you've taken a drawing class and know how to do that. Here you can see examples of the different screens on a photo. Oftentimes, too, this just comes down to price as far as what your budget is in printing. Also, understanding the different types of printing and the effect you're going to get. In the last lecture, we talked about these other two types of printing, flexo or flexography and rotogravure or gravure. And the type of printing really depends on the project. If you're printing on something non-porous like plastic, or if you need something that has much better photographic representation on here. But similar to what I just showed you with the gradient, and you can see the dots, the quality of the ink on the surface changes depending on what you're printing on. So with flexo, you can see the interior of the dots. The dots stay pretty circular, but the interior gets a little light in the ink coverage. And then with gravure, you can see, especially depending on what type of paper you're printing on, the dots actually start falling apart and not even looking all that circular anymore. I mentioned this earlier that all the dot screens in printing are laid at very specific angles so that you don't end up with clashing patterns. If you do end up with screens that are not lined up properly, you'll get what we refer to as a moire pattern. And what this looks like in printing, here on the left you can see what happens when the screens start clashing with each other. You start getting weird little patterns throughout here. What that looks like in print is, if you look at this image on the bottom, it will start developing this very kind of pockmarked look to it. So that's usually a problem your printer can fix, but it's something that you always want to be aware of if you're running off a piece on a commercial print.